Welcome to the third video of the second module. In this video, I am going to explain the solutions of homogeneous differential equations subject to the given conditions. Consider the given equation, that is y double dash plus 4y dash plus 4y is equal to 0. Given y is equal to 0 and y dash is equal to minus 1 at x is equal to 1. The solution is same, that is m squared plus 4m plus 4 is equal to 0, wherein we get the roots are minus 2 comma minus 2. Hence y is equal to c1 plus c2x into e to the power of minus 2x. Now we will make use of the conditions, that is y is equal to 0 at x is equal to 1. It becomes c1 plus c2 into e to the power of minus 2, or 2 into 0, that is c1 plus c2 is 0. So y dash is 1 minus 1 and x is equal to 1. Hence 2 becomes minus 1 into c1 plus c2 into e power minus 2 of minus 2 plus c2 e power minus 2. But c1 plus c2 is 0, therefore c1 is minus c2. And substituting these values, we get y is equal to 1 minus x into e power 2 into n minus x. That's a particular solution. Second equation, d square y by dx square plus 4 dy by dx plus 5y is equal to 0. Given y is equal to 2 and dy by dx is d square y by dx square when x is equal to 0. The auxiliary equation is m square plus 4m plus 5 is equal to 0, whose roots will be minus 2 plus or minus I, which gives the solution as y is equal to e power minus 2x into c1 cos x plus c2 sin x. Now consider this and get the values of c1 and c2. That is, by differentiating and double differentiation, we get c1 is equal to 2 and c2 will be equals to also 2. Therefore, y is equal to twice of e to the power of minus 2x into cos x plus sin x. Now let us discuss some of the particular integrals. The first type is e power ax by f of d. So e power ax by f of d is e power ax by f of a, that is by replacing d with a, provided f of a is not equals to 0. If it is equals to 0, then we will multiply the numerator by x and denominator will be f dash of a. And it continues provided f dash of a is not equals to 0. If it is 0, again one more x is multiplied and differentiated the denominator, and so on. Next particular integral of the type 2 is sin ax by f of d square and cos ax by f of d square. However, if f of minus a square is 0, then x is multiplied to the numerator and differentiate the denominator. Type 3, it is of the form f phi of x divided by f of d, where pi of x is a polynomial. We have to divide the phi of x by f of d. We'll have some illustrations. Stage 2, the particular solution of this phi of x by f of 2. So let us do it in the next video, the problems. Thank you.